Write the equation of the line in slope-intercept form that passes through the given points. So if we subtract y2 minus y1, that's a difference of 22. And x2 minus x1, 87 minus 44, that's a difference of 43. Now that's just the slope. We still need to find out what the y-intercept is. We can either write it in point-slope form and convert it to slope-intercept form, or we can solve the equation for b. We'll replace the y value and x value with one of these points. (22) times 44 will give us the numerator. If we wanted to change 50 to be out of 43, we can multiply 50 by 43 and put that on the top. Then we can subtract this fraction from both sides. And that leaves us with b equals 1,182 over 43. So in slope-intercept form, we have 22 over 43, x, plus 1,182 over 43. After catching each fish, Ethan measured the length and the weight of the fish. But once his scale fell off, he was no longer able to measure the weight of the fish. He caught 3 different types of fish, which you can see are labeled at the top of each table. Even though he was no longer able to record the weight of the fish, we may still be able to use the rest of the data to help us predict what the weight of the fish might have been. Each member of your group should create a scatter plot for one of the 3 types of fish by using the following tables. So you as an individual will only be responsible for completing one scatter plot. We are going to do the southern flounder. That first point in the southern flounder is 415, 880. So we're going to go over to 415 and up to 880. Then we have 340, 400, 371, 590, 358, 520, 320, 340, 411, 680. Work with your group to draw a line that fits the data, then find an equation for the line. Remember, we want to be as close to as many points as possible. We'll use the values from the line to help us build our equation. It appears that the point 420, 800 is on our line. You could also use the point 300, and this appears to be about 220, or perhaps 260 and about 30. Remember, these are going to be approximations because we're not super sure about the specific location of these points. So that change in the y values is going to help us find the slope. And the change in the x values is going to help us with the denominator for the slope. We're going to just approximate this to 2 decimal spots for the sake of the problem. To solve it for b, we're going to replace the x and y value with one of the x and y values from these points. So I'm going to use 260 and 30. 4.81 times 260 is 1,253.2. Subtract that from both sides to solve it for b. So our equation will say y equals 4.81 x minus 1,223.2. Use your group's equations to predict the weight of the following fish that Ethan caught. Round your prediction to the nearest 100th gram. So that's 2 decimal spots. An Atlantic croaker that is 261 millimeters long. So we'll take the equation from one of our group members to help us solve this. So here's the equation that they had. We're going to replace the x value with 261. We will multiply 261 by 2.89. Then subtract 471.4, and we get 282.89 as our weight in grams. Now we need the southern flounder that is 369 millimeters long. This will come from the equation that we used, and we're going to replace x with 369. .81 times 369 is 1,774.89, and subtract 1,223.2, giving us a weight of 551.69 grams. Number 5 is a Gulf flounder that is 323 millimeters long. Again, we'll use the equation from our peers. Replace that x value with 323. So start by multiplying 5 times 323. Then subtract 1,250. And the fish should weigh approximately 365 grams. When Ethan came home, he found another scale to use and weighed the fish. Ethan's 261 millimeter Atlantic croaker weighed 200 grams. His 369 millimeter southern flounder weighed 480 grams. And his 323 millimeter Gulf flounder weighed 410 grams. Plot the new data point for your fish type on your scatter plot in problem 1, and then draw a vertical line segment to connect the new data point to the line you fit to the data. So our point is 369, 480. And then it does tell us to draw a vertical line from our line to our point. The length of that line represents the difference between the actual value of its weight versus its predicted value from the line. So you may notice that the southern flounder and the Gulf flounder are similar in shape. This could impact the slope of our lines being close. We had a slope of about 4.81 and a slope of 5, versus the Atlantic croaker was a much lower slope. That has to do with the ratio between the weight and the length of these fish. And it should be similar because they're similar shaped. That takes care of lesson 15 from module 6. More module 6 videos should be added to the playlist soon.